I think we slowly can start because we have a tight agenda. Okay, warm welcome to all participants. Many thanks for your interest and for joining us this morning. We kick off with a first edition on Space for Agriculture, and we put together for you a quite interesting program. Before we go in depth into the discussion, I like to briefly introduce you to NEREUS because I saw there are many newcomers. NEREUS stands for Network of European Regions Using Space Technologies, and we are a European network bringing together 23 European regions and 36 associate partners. Regions are the level next to the national state for those ones who are not familiar with the terminology. It's the supranational level, and it plays an important role in many public policies that are implemented at this level. And the regional level is also the closest level to the European citizen. Our mission is to spread the use and understanding of space technologies, Earth observation, Copernicus, global satellite navigation, in particular Galileo EGNOS. We want to shape ecosystems so they get more involved in space and build their space capabilities. We are also the only network bringing together regions and space, bringing together territorial and regional policies and space. If you look at Earth observation data, it is targeted at the public sector in many respects, in particular for environmental matters and agriculture. We work with our region on spreading a better awareness and stimulating them to implement the use of satellite data in their workflows and design strategically policies and regional strategies that innovate with the help of space data. As a regional network, we work on three main axes, and interregional cooperation, partnerships, and exchange of information and best practices is one key activity of our community. And in this respect, we organize regular webinars where we bring new information to the floor and bring also or bring to the floor new European institutions with whom we interact. And in particular, we discuss best practices, good application examples from our partner region. It is very important to make regional ecosystems more transparent at a regional scale and to show their capabilities. And we are extremely proud. We have today identified two examples from Wallonia and Apulia that we will share with you and discuss with you. And many thanks for anybody who supported us in bringing the program together. With this, I will move to our first speaker. I'm extremely pleased to welcome Livia Peiser. Livia is the head of the Geospatial Unit at the Food and Agriculture Organization of the UN. Livia is already 16 years with the FAO and has a geographic background. And Livia is going to introduce to us a very important study that the FAO launched this year in February, leveraging space technology for agriculture development and food security. And the study is about how space solutions drive sustainable agriculture and support the 2030 agenda for sustainable development. Livia put the link of the study in the chat, so anybody who wants to click on it or have a look while we are talking is free to do so. And please, Livia, the floor is yours.
Thank you, Roya. Thank you for inviting us. This is my first time joining this important network, and I'm very happy to be part of this conversation. So yes, I will be. Let me share my slides. I will provide an overview of the report. Yeah, hope you can see it well. And so this is, I'm Livia Peiser, and as you introduced me already, so thank you for that. I work in the Land and Water Division of FAO. In FAO, there's a very broad use of geospatial tools and technologies for advancing food security, and because we cover not only crop but also forestry, fishery, livestock. So it's very difficult to summarize everything in this time slot. So I will just move on to first explain why it is important, why geospatial tools and technologies are so relevant for us. The first thing I would like to raise is the urgency of accelerating action for progressing our path towards the SDG. FAO is directly and particularly, of course, involved in SDG 2 on zero hunger, but as this drawing here shows, there's many other SDGs and indicators of this SDG to which we contribute. FAO is custodian agency for more than 20 indicators in the SDG framework, and SDG 2 is, of course, the most relevant. And on that, the latest state of food security and nutrition in the world, 2024, highlighted that there's still more than 700 million people facing hunger in the world, and this number is not decreasing, is still similar to figures of 10, 15 years ago. And the main reasons behind this are conflicts and climate change. So clearly the world is not on track to achieve SDG on global nutrition, but the same can be said, unfortunately, for many others SDGs for which we support countries for monitoring. At the same time, we all witness increasing vulnerability to shocks and crises. The 2024 was the warmest year on record, and the growing temperatures are already altering the hydrological cycle, with impact on droughts and floods worldwide, and this has a direct impact on food security. This means that we need more timely data, accurate data, and in spatial and temporal accuracy to inform on these challenges, and also to inform how better we are, or not good we are, in using natural resources for sustaining agricultural production. Geospatial data plays an important key role in that, and I will just show a few examples of how we use geospatial data in FAO for supporting food security activities. So one clear example is use of geospatial data for monitoring agricultural production, particularly in conflict areas. This is an example from Sudan. The Gizir irrigation scheme in Sudan is the largest irrigation area in sub-Saharan Africa, and it is difficult nowadays to monitor things on the ground. So space technology is key for advancing, for monitoring food security in the area. And we've been using a combination of commercial satellite data for validating, but largely we use as much as possible open access data, and namely from Copernicus in this case, for monitoring agricultural production. We also use a lot of geospatial data for monitoring impact of shocks. In this case, this is an example of a collaboration that we have with UNITAR, UNOSA's office in the United Nations. They also use high-resolution data, satellite data, to monitor impact of disasters and conflicts. And we came with, and we in FAO, we look at the impact on the agricultural sector in particular. So we've been constantly monitoring the impact of the war in Gaza and see how this impacts agricultural production, but also infrastructures to the extent possible. We also work a lot on land cover and crop type mapping. So a couple of examples, in Zambia, in Tunisia. In Tunisia, we also went down to crop mapping, but we do this in many countries, of course, and we also are active in setting standards for land cover classification that are also applied in an ISO standard for land cover that is widely used. Another example that I wanted to make, because I think this will be also addressed by other speakers, we also maintain a remote sensing based database on water consumption in irrigation, so actual evapotranspiration. This is an example of an irrigation area in Pakistan where we monitor in near real time every 10 days actual evapotranspiration with the energy balance algorithm, again using open access satellite data. And this is important, of course, for monitoring SDG 6.4 in particular, but it's also important because this can inform irrigation practices and provide advisory service to farmers when it comes to irrigation. So this slide shows that the data is also used at field level. In this case, it's an irrigation scheme in Tunisia, where the local partners there in the National Agricultural Research Agency developed a smartphone application that uses our data to inform on irrigation timing and quantity for the different crops in the scheme. So this is a very short overview of some key applications of geospatial data for agriculture that we maintain at FAO. However, these tools are very much underexploited on a global level. And we feel, well, we see that there is a need for improving collaboration in the space value chain to maximize the use of emerging space technologies, but also positioning system and remote sensing. There's also a need for partnering to improve and strengthen technical capacities at a national level. Unfortunately, often the countries that need this data the most are the countries where capacities are weaker. So we need to work together to improve and to strengthen these capacities. And there's a need to promote international standards that can be aligned to national requirements. So there was a report in 2015 on the Space4Agriculture Development and Food Security at a United Nations level, also developed by United Nations Office for Outer Space Affairs, and we thought it is about time to come with an updated document, and that's what we launched last February. Again, collaboration with the United Nations Office for Outer Space Affairs. And I will now show in the next few slides a little bit the structure of the reports, but as said, I also put the link in the chat, so I will not go into the details, but just provide a summary of the structure of the publication. So there's an introduction on the role of space technology for agriculture and food security. There's also a description of the role of space technology in the broader value chain of agriculture and food systems, and with the distinction between upstream, midstream, and downstream segments. We look into challenges and opportunities for strengthening these capacities and applications of space for agriculture and food security. We look at the future and trying to understand what are the next immediate but also longer term opportunities, and of course we conclude with some recommendations. So when it comes to describing the role of space technology for agriculture and food security, I think we need to be aware that it's a system approach, not it's a combination of different aspects. So we start, of course, with the sensors, with the remote sensing, but also global navigation satellite system, because these are also very important in agriculture for precision agriculture, but also more in our field for example, field data collection, monitoring infrastructure, and so on. There's, of course, a big part that goes about using and strengthening capacities for using cloud computing, machine learning, other type of geospatial analysis, and integrate it with field data. And we always need to keep in mind what is the ultimate goal, and in our case, that is to support agriculture and food security policies at country level, and at the end benefit the farming communities around the world. I just want to now summarize this distinction between upstream, midstream, and downstream segment of the space area. And I think it's important to have this in mind, because these need to be the contribution of space to agriculture and food security comes at different levels in these different streams, and it's we need to have a systematic approach. So when it comes to the upstream segment, that has more to do with data acquisition, that is of course through satellites, but also through non-space-based data. And it's important that requirements are informed by agriculture, by users and experts in the agricultural domain right from the start. The midstream is more about data processing, storage, and access and integration of data. And there, of course, the agriculture use need to be kept in mind when thinking of how making these data accessible. In our case, for FAO, we need to think of how this data is made accessible and distributed through two countries in the world where maybe internet access is still a constraint, and think of how to increase the effectiveness of data publication. The downstream is where, of course, there's a stricter and a closer role of agriculture expert in defining how the data can be integrated, developing agricultural models that monitor agriculture in these different aspects. And of course, we always need to think and to keep the end user in the picture. So this is to say that when we think of making space technology useful and more used in the agricultural sector, we need to think of the different segments in a systematic approach. And in addition to that, it's not only the space-based data that needs to be considered, but also in agriculture, but not only. There's a lot of data that doesn't come necessarily through Earth observation and satellite data, but a lot of field data is still needed and needs to be integrated in this overall picture. And that's where data and harmonization of data and standards become particularly relevant. So as I mentioned, we developed standards for ISO standards for land cover classification. We maintain tools for characterizing land cover legends, and so that they can be compared with different legends and made useful for a different reporting mechanism. We constantly, we make sure that our data and tools are in line with Open Geospatial Consortium recommendation, and of course the UN GGIM network. At the end, the data needs to inform, of course, users or farmers, policymakers at national and subnational level, but they also need to be relevant for key framework agreement in agriculture. And these include, of course, the 2030 agenda, the Rio conventions, the COP on biodiversity, climate change, and desertification, We also contribute to GeoGLAM, so the Group on Earth Observation Global Monitoring Initiative for Agriculture, and particularly to the essential agricultural variables, and as mentioned, UNGGIM. In the report, then I'm now almost at the end of the overview. We conclude with some key challenges and opportunities. I'm not going to read this because it's in the report. I'll just highlight some that may be I don't know, discussed in this webinar. And also in this case, we organize these challenges and opportunities by segment. So when it comes to the upstream segment, there's opportunities for enhancing satellite missions development through standardized agriculture-specific requirements. We are already part we have a good collaboration with ESA, with the European Space Agency, and we participate in mission requirements definition. So, for example, the land surface temperature mission, the new LSTM that is hopefully coming up soon in the next few years, we are actively contributing to the mission requirements. And I think that's a very good example of how this partnership should work. I mean, so that we are, the agricultural community is engaged in the requirement formulation from the start. When it comes to midstream segment, there's opportunities for working together to enhance data accessibility and increase open data initiatives that we are, I mean, champion of in FAO. All our data are open access. And in the downstream segment, of course, there's, for example, need for increasing the coordination for enhancing in situ data collection and open access for agricultural application. So these are just examples of what we highlighted in terms of challenges and opportunities, and we conclude with an outlook and note that there's so many missions coming up that are relevant to agriculture, and it's important that we come together and enhance our partnerships and collaborations to make sure that we can make good use of all this new data. I think there's still underutilized, at least on a global level. I mean, I always talk with a global angle point of view, but of course in Europe it might be different. So to conclude, I think that the report just highlights that there's a need and for in continuous investments and partnership in enhancing the use of space technologies for food and agriculture, because there's a clear need and urgency for using these data as decision-making processes for transforming agri-food system. So that's our appeal to the space community and the agriculture community. And with that, I'll thank you, and I'll leave here again some contacts and the link to the report. Thank you very much.
Thank you, Livia, for this insightful presentation. It was really interesting. And I like to open a first round of questions or comments. Please put your comments in the chat. I have also one for Livia. Livia, we work very much on the same strands. A lot of things that you presented sound very familiar to us. We tackle those things from a local and regional perspective, and we have also a collection that you might have seen in your preparation, the collection Copernicus for Regions, 99 user stories, and we have a whole chapter on agriculture. And in the discussion with our regions, we see it is in almost all our partner regions top on the agenda. It is the area where the use is the most advanced. And I think for Europe, it's a particular important sector, because a bulk of the EU budget is number one of the largest segments of the EU budget, and let's say an important segment of the agriculture EU budget is implemented at the local and regional level. So agriculture plays a key role in most regional economies of our partners, and the discussion of agriculture in the context of water scarcity has become much more pertinent. The discussion of soil management and all the impacts that come with climate change have arrived in Europe. And we see also that the question of healthy food production is gaining more and more importance. When listening to your presentation, one a question came to my mind, and it was very close to what we're working daily on, and I'm interested to hear your vision. We have the data. Copernicus produces every day immense amounts of data. We have different data sources. We also start now working and integrating Earth observation data with artificial intelligence, with computing. But we see it is very, very difficult to implement the use in the regular workflows of public administrations. We see in the use cases we work with, they are fantastic when we present them in an ESA conference or in a publication. But if we with our stories, with the 99 user stories, we went also back 2 years after, 3 years after, to look what happened to them. And we saw how difficult it is to really get them in a systematic way into the workflows. And we see amongst our partner, despite the need, despite the pressing challenges of climate change, we have no systematic uptake across Europe. It is really a puzzle of coincidences in a way. How do you see this at a global scale, and what can we do for a more systematic approach?
Yeah, that's a very interesting question. I wish I had the answer. I think well, what we can see is that I mean, it's very interesting for us to hear the European experience, because I mean, in our daily work we work more often with countries that supposedly have less capacities and institutional will to institutionalize use of remote sensing. We also, on the other hand, the countries we work with in many cases have even more urgency when it comes to water, for example, water scarcity. We see the examples that I showed on Tunisia, but all the North Africa, Near East have, of course, an urgency in using data for I mean, remote sensing data for improving water use in agriculture. Let's say my reflection is that there needs to be a combination of higher level political will. For example, recently, well, a couple of years ago, the League of Arab States released water allocation guidelines that include use of remote sensing for monitoring water use and informing water allocation and through water accounting. So a higher level political commitment is definitely needed, and platforms like this one are important for informing and driving the dialogue in that direction. On another level, there needs to be, as mentioned, efforts in strengthening capacities in the countries at different levels. But also, we realize that there often needs to be a combination of public and private sectors, or in many cases, private sector is still instrumental for making the data accessible in the right way to public institutions. So depending on the country and on the context, we need to think of ways of strengthening the partnership between public and private sectors. And we need to also on a, let's say, more on the upstream, on the space data provider. I think what is important is committing to continuity and open access data, and Copernicus program in that sense is it's really a huge initiative, and we are so happy that Copernicus program is there and is going to stay there and provide open access data for our applications. But that is not enough. There's still too many when it comes to weather, for example, monitoring climate and weather forecast in countries that are facing challenges when it comes to water, drought and floods and so on. There's still a need to work together to make sure that open data can be used by those who need it the most. So open data, capacities and political will, I think, are the three main pillars that need to be strengthened. That would be my reaction. I see there's a couple of questions in the chat.
Yes, I will come.
Okay.
I will come. Many thanks. That was a good start for us to take. We have a couple of questions. Charles Mangi, thanks for your great work FAO is doing. My question is on efforts by FAO to co-develop solutions with user community, especially those in the global south. The challenge is on uptake. Is the user community does not understand how the solution have been developed.
Yep. No, that's a very good point. The example I made, for example, in Tunisia, where we developed we didn't develop, but the national institution there developed an application for irrigation advisory services. That is a clear example of co-development. We see that there's no other way to go about application development than engaging communities and end users from the beginning in the identification of the issue, in designing and developing a solution. So it takes time. It takes time and resources to do properly a co-development process, but it's the only way to go for making sure that the applications we developed are then used. There are I don't know which countries the question comes from in particular, but there's many countries where we are active, where we are engaging with communities and end users to develop this type of application. So I fully agree with that point.
Thank you. One remark, please mute yourself. There are some people we can hear the noises. Thank you, Livia. And we have another question by Johannes Schmidt from Jura. To what extent do these analyses already play a role in policymaking? And how can the advantage of Earth observation be incorporated even more into legal frameworks?
Yeah, well, I think I addressed to some extent, this is similar to the question you made. So yeah,
okay.
In the interest of time. And the second question is already there from the same person. So maybe I can just directly.
Yes. Do you see any benefits of other EU space assets, such as satellite connectivity, maybe also in smart combination with Earth observation?
Yeah, definitely. I mean, beyond Europe, well, also in Europe, I'm as I said, I'm not too much aware of things in Europe, because in our work we focus on countries beyond Europe in most cases. And I can say that satellite connectivity is definitely an interesting. I mean, it's important. We provide these solutions for and use of open data and smartphone applications and so on. But then we I mean, we run into the issue of lack of connectivity, particularly in rural communities. So I think this is something where the space technology can really play an important role in advancing on solutions for making connectivity more broad and accessible for rural communities. Yeah. So. Yeah.
Okay, we allow another 2 questions, and I think then we have to move on to the other speakers and can maybe come back in the final discussion. I have one more question from Fabio. What have the advantages of using spatial observation in the agriculture field translated into so far from a practical point of view?
So I think this refers to very important question, and how do we make this information and data useful for farmers at the end? That's our ultimate goal, and we do have examples. So what I showed in Tunisia, but we have similar examples in Jordan and Egypt and in Kenya, where through a long process, we ended up making the data useful for decision making at field level. But there are many examples. I acknowledge that this is still very much time consuming, and there are limitations in the space, in remote sensing data, when it comes to use of this data for smallholder farmers. We work a lot in countries with cloud cover, and that make the data not usable. So there's so many both technical and resources-based limitations. We do have some positive examples, but it's still a long way to go, and that's where I hope this community can come together and improve the collaboration.
Thank you. I have a last question from Jean-Claude Koya. Thank you for this great initiative. I just want to know if the platform will be accessible to farmers and if the data will be updated very regularly. And finally, if the data will be searchable with existing stelliatary data systems in the countries.
Not sure what platform in particular this question refers to, but I can put the link. In FAO we have a agroinformatics platform, so an open geospatial platform where our data is made available. When it comes to the data, for example, I showed on water consumption, this data comes every 10 days regularly, and it's important. I want to highlight the fact that we developed this database for monitoring actual evapotranspiration, and because of we could demonstrate the usefulness of this data for our member countries, the Copernicus Land Monitoring Service decided last year to include a global evapotranspiration product in their portfolio. So hopefully, after the end of 2025, there will be an additional global land service product that monitors actual evapotranspiration every 10 days at 300-meter resolution. And with the LST mission, the Land Surface Temperature Monitoring mission coming up, we also hope to improve the accuracy. So that is to say that Copernicus luckily is making this data available in near real time. In at least some of the data that we need is made available by Copernicus, and with that data we can populate and maintain these platforms regularly. Still, there's a lot that needs to be done for making this accessible to farmers. So be it through applications or by reinforcing the capacities of extension services in using the data. So there's a lot that still needs to be done.
Many thanks, Lydia, for this exchange. I take from what you said that Copernicus is a unique tool that we are as Europeans privileged to have access to this source of knowledge, that we have a continuous and stable data access. And you highlighted, for improving the situation, we need open data, better capabilities, and a strong political will. And when listening, I hope at a European scale and at a global scale, we will be able to enhance and strengthen cooperation. Then that is a really important asset to better advance with all these challenges.
Yeah, thank you for summarizing.
Thank you. Thank you. Then I move on to the next speaker. I'm very glad to welcome Vasilis Kalugiu and Stefan Schneider from the EU Agency for the Space Program. Vasilis, you will speak about downstream innovation in the agriculture sector through Horizon Europe. EUSPA is the agency at the European scale that is charged with developing the downstream sector. And the Horizon Europe program is one of the key programs to support innovation and research in Europe. Please, the floor is yours, and let us know more what's going on in the agriculture sector.
Thank you very much, Roya. Thank you for this invitation. It's not the first time we join one of your events, and we're always happy to contribute. And I think that's also our participation and willingness to always contribute is also, I think, a testament of the good work you do in NEREUS, at working mostly on regional level, which in a broader sense contributes also to our mission. So it's important that we reinforce, let's say, this collaboration that we have. I'm here with my colleague Stefan Schneider. While Stefan, can you hear us?
Yes, I can hear you.
Okay, and we can see you as well. Maybe I believe since you will deliver the majority of the slides, maybe you can try to share the screen.
1 second.
And I think our material, it's a bit complementary to what Livia touched upon some very interesting aspects. And we see, I think, the argument in a slightly different complementary perspective still. We can see the slides, yeah. If you can share now, I will start and then pass you the floor. Can you maximize maybe?
I did already. On my screen, it is
okay.
maximized.
We see the other. Okay, we see the other screen. You can, yeah.
You don't see it in full screen, right?
We don't see it in full screen. Yeah.
Okay, let me try something else. 1 second.
Yeah. So both me and my colleague Stefan, we work on the Market and Downstream Innovation Department, MDI, in EUSPA. And one of the first slides we have basically is explaining a little bit, because I don't know if the audience knows our institution. EUSPA is the EU agency for the space program. And
I'm working on it, Vasilis. So you just can continue. I will try to fix that we are going to be able to see the full screen. So sorry for that.
No worries.
But if you don't work with WebEx, usually it's a bit tricky for me. But I will try to solve it.
Okay, let me go vocal then on the first, talking a bit about our mission, because maybe not all of the audience who participates today is aware of us. So EUSPA is an institution. It was we were before called GSA. We were the GNSS, European GNSS agency. So primarily work in GNSS is the global navigation satellite system of the European Union, Galileo specifically. And since 2021, through an EU regulation, we were established with a different name and a more expanded mandate. Our mission is to work on the exploitation of the EU space program capabilities, on the security of the space program asset itself, with security accreditation, operation of a Security Monitoring Center. But most importantly, and this is why we're here today, on the utilization, on the market development and communication, and the user uptake. So to make sure that whatever infrastructure we put in space has been utilized and exploited for the good, and we have businesses at EU, but even abroad, utilizing space data and services. And as you know, because I heard a lot the word Copernicus, and the observation aspect, of course, is very relevant for agriculture, but we also have the element of navigation, which is also an enabler for, I would say, digitalization in the agricultural domain, but also the connectivity, which was mentioned before in the discussion, and also on the questions, which we also believe plays an important role of agriculture. Yes. Thanks, Stefan. Thank you. You solved it. Excellent.
Yes, thank you. That was my mission for Friday. I achieved it.
You can
go
pass
now.
to the next slide, because I already spoke about our mission.
Okay.
So we will see a bit more the perspectives of the market side. How do we build what we call the EU space downstream ecosystem? And Livia's presentation talked about the upstream, the midstream, and the downstream, just highlighting downstream in whatever comes out of the data and the services themselves. And in order to do that, of course, we work on market intelligence. So you will hear in the slides we have in the beginning how we approach the aspect of understanding the market, because this is our target. So we have some material on the value chains that we work on, and the analysis we do on the market, how we work with the users, because a lot of them material and initiatives means understanding and working with these users. Who are these end users? Talking about farmers, cooperatives, even companies that are active in building assets that can be used by farmers. And then we're going to show you some of the projects. Was primarily Horizon Europe, but it's not Horizon Europe the only tool we have. We also have entrepreneurship tools. Maybe my colleague Stefan will say a bit more on that. So our target is, and this is where I will close and pass the floor to my colleague Stefan, to help these companies add value, create and build, I would say, sustainable agricultural businesses that exploit EU space program data and services. I think the floor is yours, Stefan.
Yeah, thank you very much, Vasilis, and sorry again for the little technical issue we had here at the beginning, but I'm very happy that it's solved now, and thank you also very much for inviting EUSPA to this webinar. Very much appreciated, and as Vasilis already said, I'm going now a little bit into the details in terms of agriculture and space, what EUSPA is doing, with which players we are working with, which materials we are producing, because I think that could be also of high value for you. And if we talk about market intelligence, we will also talk about this on the next slide. We will have a report published, which we are calling Market Report, where we have a dedicated section on agriculture. And overall, for us, it is important here at the market development team, market development department at EUSPA, together with Vasilis and a lot of other colleagues, to create a new generation of SMEs, startups and innovators in the EU. And then also that includes the ecosystem of agriculture. And then, of course, what we also have to do is that the EU space downstream industry helping with their competitiveness, and also promoting synergies among the different components of the EU space program, like Galileo and Copernicus. So our target, to be short, is the customer-focused companies that add value and exploit the EU space program data. So we are working with from small startups to big corporates in Europe, which are using our products and services, and we are helping them to implement them. And we also try to create an ecosystem in this regard to support the digital agriculture. Here you can see something that I've already mentioned before. It is the so-called market report. You can find this market report actually on our website. So if you just Google USPA market report, you will find it. And here we have very close looks on the market in terms of agriculture. So what you see here is the revenue from EO data. On the next slide, you will see the revenue from GNSS. And we are having a very close look on the different sectors in this EO for agriculture, beginning with vegetation monitoring, crop yield forecasting, cap monitoring, up to soil condition monitoring and carbon capture. So we are trying to have a closer look on all the different segments in agriculture in terms of EO. And then, of course, this also includes like the environmental monitoring, natural resources, and also operations management. So, for example, I was talking about big corporates that we are working with. So, for example, we have very close contacts to a corporate called Glass from Germany. They have their own farm machinery guidance system. So we are working with them, for example. So the idea is always in the market development team to support the European industry from small to big. But not only, because of course we are also in contact with farmers themselves. Here you can see the value chain of Earth observation that we have found. So beginning with data providers from Airbus, and of course our Copernicus Sentinels, we have the infrastructure providers, we have platform providers which are important, and then we have the EO products and the service providers, the information providers, and then of course the end users, which are usually also farmers, but not only. It is also paying agencies, wine producers, and also agri-insurers, which are also important in this field. Here you can see the agricultural value chains for GNSS. It's a bit similar, but not only. And here we are also working together with the augmentation service providers, and then component and receiver manufacturers, system integrators, and then of course again with end users like farmers and others in this area. And this is something what we are doing every 2 years for agriculture. You can also find more information on our website. There you can also find the old report. We had the last UCP, as we call it, user consultation platform, 2 years ago. What are we doing here? This is a platform. This is usually a one-day event where we invite all the stakeholders in the agricultural domain, but not only, because we also talk about mobility, we also talk about environment, we are talking about aviation. I think we have like 17 segments within UNOSA, but of course, as we are talking now about agriculture, this is the topic I will explain a little bit more in detail here. So 2 years ago, we had a UCP, a user consultation platform in agriculture, where we invited farmers, associations, corporates, startups, scale-ups, to meet us and to discuss with us the services, the products that we are providing at the moment. We were also having discussions about future services, because this is very important also for us to see what is the market doing, because of course we are not farmers ourselves and we are not constructing harvesters ourselves. So we rely also on the feedback from the market. And this is a starting point for our programmatic actions and also for all the initiatives regarding research and development. And those inputs then we take into our draft programs for the European Union Space Program. And the people who were there actually were farmers, agroinsurers, cooperatives, agronomists, paying agencies, international agencies, research centers, etc. So it was a whole big ecosystem that is somehow related to agriculture and space. And this year, it is not sure yet exactly when, but I'm happy to keep you posted about that. We are going to have this user consultation platform again at the end of the year. It is also possible to join online, of course, and also to discuss with us the status quo, but also future trends, and give us input for the further development of our services and products of EU services in space. Now I'm going into give you a short overview of some projects that we were doing all around Europe. They were all part of, or they still are actually, some of them, of Horizon Europe. I won't have the time to go super into details here for the projects. If you want to know more about those projects, you can either contact me or just can Google them, because every project has its own webpage where you can find more information and more detailed information about that. And also, if you would be interested in participating one of the Horizon Europe course in agriculture, you can also find more details on our homepage. Otherwise, if you don't find it, feel free to contact me. I am always happy to help. So this is the first project that I would like to talk about a little bit. This is called MAGDA, and this is actually a tool chain for soil and atmospheric monitoring, weather forecasting and severe weather, irrigation, crop monitoring advisories, and this tool set is using Galileo, Copernicus, and the drone data at its core. And you can see the drone actually on the second picture here. Actually, I was there myself when we tested it for the first time, because as you can see, the drone is going up on this little picture, and it is fully automatic. So you don't need to do anything. The drone starts itself and comes back itself, collects all the data, and then even this little box is closing to protect the drone. And then when the drone has collected all the data, it is sent to the cloud, and then all the calculations are made automatically to help the farmer to be alerted for severe weather or if there's a problem with the irrigation. Here you can see how it is all connected with GNSS and meteorology, and you can see that in the future the decision making of a farmer should be much easier than it is today, especially if it comes to augmented weather forecasts. The test that we did was on a winery in Burgundy in France, where weather is a very, very sensitive issue, because if you have bad weather for a longer period, this really could harm the wine stock. So it is very important for the wine farmer to know the exact weather forecast, and this program here is going to help him to make better decisions. This is another project which is called Agribit. It is about artificial intelligence in precision farming. The idea behind here is to use AI for precision agriculture with innovative technologies. The program has already been closed, and synergies between GNSS and Earth observation wanted to make the precision agriculture more accurate and in a more continuous way. We had 3 test sites, one in Greece with peaches, one in Portugal with tomatoes, and another one with vineyards in Italy. So the idea was also to use it for different cultures, so that you can adapt this AI actually for several use cases.
Stefan, thank you for these extremely illustrative cases, but could you kindly come to the end? We have another 2 speakers.
Yes, of course. So then I will hand over back to my colleague Vasilis, and thank you very much for your attention.
Yes, what we could show maybe, Stefan, before closing, show also a little bit the dinosaur slide, because while you were speaking, I put some slides, some links on the chat, so maybe participants can see more details and technical details. But before concluding, just to say, a lot of the things you see is a more generic, synergistic use of space capabilities in the EU Space Program. And this is important because we bring different components. Earth observation itself will not solve all the problems of the farmers, and this is where in situ data come in. And what you see here is the example of dinosaur. So it's not all that we do with something for European farmers, which is important for sure, but we also try to bring these technologies out of Europe, internationalizing EU Space Program data and services. This is an example of dinosaur specifically applicable in Colombia, where cloud coverage is a bit of an issue, and there we work, of course, with Sentinel-1 data, which are synthetic aperture radar data. And the next slide, we wanted, apart from giving you the overview of our portfolio, make also the linkages on something that Livia already mentioned a lot, the food security aspect. And there I have presented this in the past. It was an interesting study that I'll put the link also on the chat, that we did on how Copernicus data can be used to quantify the impact of war. Food security is not only about the drought or floods, but also about the impact that war can have in agriculture. And this is something we do together with colleagues in JRC, but also some Ukrainian researchers which have some better overview of what is happening on the ground. And we published this 1 year ago in the framework of our initiative, which is called EU Space for Ukraine. We'll put the link on the chat. And I think this is how we wanted to close this presentation. Thank you, Roya, for keeping us a bit on track. We had even actually more material to show, projects that work on soil quality, and a couple of other slides. But I think the important is to show how all the different components of the EU Space Program contribute in this project. It's not only the observation aspect, but also positioning, which is quite important. Thank you for having us.
Many, many thanks to both of you. And those cases were very interesting and gave us appetite to invite you to one of the next webinars. So we got new inspiration. I like to move on to the next speaker, and I think then we do the round of question after we have heard the best practice presentation from the regional level. It's very important to us to bring concrete examples, concrete user stories from the users from the local and regional level to the floor. And today we have a best practice from Wallonia, grasslands monitoring in Wallonia using Sentinel-2 images. Kozmin Lukan Danila, senior researcher from the Walloon Agriculture Research Center. Please, the floor is yours.
Thank you very much, Roya. Thank you. You can see my presentation in the full.
Yes.
Okay.
But it's not in the full mode. We see also the other slides at the side. You need to push the little icon very, very left.
It's better now or not?
If you go down to the down, very down, where you have also the.
I think I have to find a Stefan solution. it's the same problem.
Okay. Well, okay.
I don't know if I can.
Maybe not to lose time. Go ahead.
Okay. Okay, thank you very much. Anyway, I'm Cosmin Lucou. I'm working in Belgium in Wallon Agricultural Research Center, and I have the pleasure to present you today the results of one project in the grassland monitoring in Wallonia using Sentinel imagery, but not only. And we did this presentation with my colleague Yannick, Viviane, and Aline from the public administration of Wallonia. You know about the grasslands. It represents a major ecosystem in Europe and in Wallonia. At European scale, the grassland, permanent grassland, cover more than 34% of utilized agricultural area. It's really a huge area, and it's really important. In Wallonia, it's a little bit more in terms of percentage. The permanent grassland cover 42% of utilized agricultural area. And for sure, this distribution is different, depends on the regions, climatic and agricultural region in Wallonia. Could arrive at 97% of the utilized agricultural area in different regions. It's not only economic importance, but grassland provide many different ecosystem services. I go quickly through that, but just to give you an overview about that, there are different ecosystem services from biodiversity, carbon sequestration, nitrogen, phosphorus recreation, and so on. And it's really important that the protection and sustainable management of grasslands is critical for protection of biodiversity and climate. Going more in the detail of objective or of project, it's estimation of the grass biomass at the parcel.
Apologies, Cosmin, can you please check, because you're not sharing the slides. Thanks so much.
Okay, I'm... Okay, Matt. You can see it?
Not yet.
Not yet.
Cosmin, maybe you can send me your presentation. Okay, now we see it. But remember to change the slide when you change the content of your speech. So now you are slide 4.
Yeah, but you can see the...
No,
yes.
But the problem is that when you touch the slide mode, it opens in a different window.
Okay. Maybe I can send you the presentation. I'm sorry, but...
If you try to share your screen, do you share screen or do you share window?
I try to both.
Okay. And now, if you click presentation, do you see full view in another screen?
Yeah.
Okay. Yeah.
No, I have only one icon, but it's one screen. But doesn't work.
Yeah. Okay. Can you send me maybe you can continue, Cosmin, not to lose time, and send your presentation to the email I sent you now in the chat.
Okay.
And then I can start sharing it from my side. That's why it's important to have the presentations beforehand. Okay, can you see my email in the chat?
I can see the email on the chat. Okay. Margarita email. Okay.
Yes.
Okay.
Yes. You can send it to me and you can continue talking, and then when I received it, I will share it.
Okay. Yep. Yeah. Let's try with this one. Okay, I'm sorry. I will try in this way. You can see the slide?
Yes, yes.
Okay. Yeah. Anyway, the estimation of grass biomass and at parcel and farm scale, it's objective of the project, because the grassland management, it's therefore complex and challenging, especially in the climate change context. If we are doing classical field measurement, it's time consuming and it's take a lot of time, energy, and money. And the idea of this project, it was to propose a decision support system for the farmers, but also for the public authority to estimate for the assessment of extreme weather event impact on early yields. The project, it was Sunshine, a 3 years project with different partners, Wallon Agricultural Research Center, University of Louvain-la-Neuve, Fourage-Mieux, and LVO were participated on this project, and the project was founded by Wallon Recovery Plan. Yeah, this is the what kind of data we are used in this project. It's really important. I stress also that the importance of field data as reference data and also used for the calibration. And our approach was to use satellite imagery, but you know, in Belgium, it's a little bit maybe as in Colombia, we have a lot of clouds, and we have long period without optical imagery acquisition. And we try to combine the both satellite imagery and the grass grow model. For this approach, we had a lot of field measurements made in the 2022, 23, and 24 in the field, on the grasslands, about compressed sward height, fresh and dried biomass, also management calendar and grass quality. I go further. If we are using only Sentinel-2 imagery, we calculate the leaf area index from the Sentinel-2 data, and we calibrate with the field measurement, and we can obtain accuracy about 2 centimeters in the mean average error.
Sorry, Cosmin, I shared your presentation, the one you sent me. Can you see it? I shared it from mine. Can you see it?
Yeah,
it's
I see.
Slide 5.
It's a PDF, yeah.
Yeah, it's a PDF. You see it, right?
Yeah.
Okay. Let me know when I have to change the slide.
It's slide 4. You can go for the slide 5.
Okay, this is 6.
Okay.
This one.
Okay. And we can see the accuracy of grass height estimation using Sentinel-2 imagery. It's so good. We are so happy with this kind of results. We are able to estimate the biomass around 370 kilogram dry matter per hectare. It's so good results. You can go to the next one.
Yes.
Margarita, maybe you can also put the full screen yourself.
Yeah.
I'm sorry, no.
Doesn't work, I think.
So now
Okay.
it's again uploaded.
Okay.
This one, right?
Yeah,
Okay.
we can go to this one. And it's an example of the long period during which we don't have any Sentinel-2 acquisition. It's more than 1.5 months without Sentinel-2 acquisition over this field. And the idea it was to use a grass growth model. We used ModVG, it's a physical model using different inputs and to estimate the grass growth. But for this model, we need information about mowing and grazing. At the beginning, we estimate the mowing grazing using Sentinel-1 coherence products, but unfortunately, the Sentinel-1B it was not operational since 2021. Now we're waiting for the next one, Sentinel-1C. It's already on orbit, and we are waiting for the data. But we tested also a different way to estimate mowing grazing dates using indices CropSAR proposed by Terrascope, by Vito, and the results are so interesting. You can go to the next slide, please. And just an example about the accuracy of in the left part, accuracy of biomass estimation using only grass model. We can see that there are different outliers, and especially during the fall period. And when we use the input from satellite LI, we can obtain a much better results. In terms of, if you go to the next slide, in terms of quality, we can see an improvement of 70% in RMSA results, metrics, and for the fall period and also for the summer period. Next slide, please. Okay, this is an example of the estimation of the grass biomass at the parcel level. It's a print screen from WALERB. It's a decision support tool, which will be available in the Wally Smart platform in August, I think. We can see in the left graphs that we have the model in the green, and each time when we have Sentinel-2 acquisition, we force the model to go to this biomass value, and also we can see the date with mowing or grazing events. The next slide, please. Yeah, and the last example, it's to calculate the early yields at the farm scale and to estimate the impact of extreme events as drought period, drought years on the grassland productivity. We take two farms.
Could you kindly now come to the end because we're running short of time?
Sure. Just to present you these two farms, and you can go in the next slide to see the results of this analysis. We can see that we have in 2020, it was a drought period with a less biomass in the grasslands for the boat. We have in the left part the graphs with estimated biomass using our system, and in the right part the reference data coming from the field measurements. And if you go to the last slide, please, we can have the same results at regional level, and we see that 2020 and 2022 there is a loss of the yield on the grasslands at the regional level scale. Thank you very much for the presentation, and the last slide you can have my emails, and that's all.
Thank you very much for this illustrative presentation. I'm pleased to give the floor to the next speaker, Pietro Sciusco from Planetech Italia. You bring to us a best practice from Puglia. The floor is yours.
Yeah, good afternoon, everyone, and thank you, Roya, for the invitation. I'll try. Let's see if I have a better luck with the sharing. Okay, I will try to do this, and I will try to put in full presentation. Let me know if you guys can see that.
Yes, Pedro.
Pietro, everything perfect. We see
Amazing. I got all
everything
the feedback, the good feedback from the previous presentations. Livia was actually pretty good. She didn't make any mistake in terms of presenting. So as Roya was saying, I'm providing you a few tips about a lesson learned from one of the project that is basically a pilot. It was a pilot project, like a feasibility study leading to a much bigger project that we are working on. Currently, it's an ongoing project. And the main topic is water needs estimation for agricultural land management. This is the brief agenda. I will go with a very quick self-introduction just to say that I joined Planetech Italia, which is a company that has been operating for 30 years now in the space sector, providing services for the Earth observation, using Earth observation different thematic areas. And I'm currently dealing with the agricultural projects. Okay, so I joined 2023 and it's still going on. So regarding the water needs estimation, or the interest in study crop water use and needs, this is a bullet point that probably who is familiar with the topic already knows. So these are all the important topics that we need to keep in mind when we deal with agricultural land management water needs estimation, such as knowing that we need to use in an efficient way water resources, that we need to maximize the crop production and minimize the risk of water management. Of course, no like decreasing the health of water resource, as well as reduction of cost production, environmental impact, and support to agricultural policies. So within all this framework, within the major framework that we have at the European level, such as the Water Framework Directive that so far has been out there for 25 years. In this high level graph, just showing you what we are following as member states, but also as to know what the target of the user of the products that we eventually put out on the market are going to be. So, for example, we have the European Union that through the Water Framework Directive, drafts these objectives such as water protection, water quality restoration, sustainable use of water, which are basically supported by the previous bullet points that you saw. And the European level, of course, the EU members are requested to, through the basin authorities in this case, they are basically providing drafting these river basin plans and programs to implement these objectives by the Water Framework Directive. And just for instance, the Southern District River Basin Authority is one of the end users, the pilot user, end user that we consider for our projects. And their mandatory activities basically doing, producing these water management plans, these WMPs, for all these actions that you see here on monitoring of quantitative water bodies status, the monitoring of water resource uses, the definition of water and hydrological balance, and definition of water price. And just to give you an example of the activities that in this case, our user is doing is basically quantification. They are in charge of the quantification of these UAA, quantification of the irrigation area and type of irrigation systems, as well as identification irrigation consortia within the district. So basically, they do this through reports. They are, to me, are kind of vintage in style, like the way that they produce these graphs and charts. But this is just to put out there that we are trying to go into this direction to help the river basin authorities in whatever they do during their mandatory activities. Okay, so let's let's see where the Earth observation can help in this case, what we think is going to help. So we said that the River Basin Authority, through the water management plans, they do the water balance, okay, at district level for different regions. And they have to eventually tell the irrigation consortia, look, you know, you can provide more or less water to these farmers. They are requesting the water. And where is the EO coming in? So let's hypothesize that the farmer goes to the irrigation consortia, they ask for water, and the irrigation consortia goes to the River Basin Authority, say, you know, for this irrigation season, we need all this amount of water from these farmers. So thanks to the support from Earth observation, this was provided from the previous presentations as well, as information. We can provide information, useful layers, products that are basically helping the river basin authorities to make better decisions in this case, okay, as a trade-off to update, of course, the water balance plan. And so to make a real decision in near real time, also like a consultative at the end of the irrigation season, a consultative decision, okay? And of course, these are the advantages of using Earth observation. There are many disadvantages as well, but let's just be positive in this case. For Plantech Italia, the importance of this topic is I wanted to just report in these bullet points, such as all these projects that we are working on. Some of them are already closed, and others are still ongoing, and other proposals that we work on. And the use case that I want to provide you today is this Riparti project, where we had the objective, the main goal of detecting crop rotation estimation, detecting a crop rotation for the estimation of crop water needs in northern Apulia region. So this is the overarching goal, was basically developing this methodology that we need to build as an internal skill in Plantech Italia for other projects that we are working on, such as the estimation of crop ET, by combining approach of the FAO 56 methodology and Earth observation techniques. So the objectives include the mapping crops and crop rotation, estimation of crop coefficient using Earth observation data, estimation of evapotranspiration of crop by the combination that I was mentioning before. So these are the three objectives in a sort of schema that I provide here, just to highlight also the data the remote sensing data that we use, as well as other ancillary and fundamental data for the water balance model by the FAO, the crop watt. And so here we mostly use Sentinel-2 data, along with, of course, in situ data for the training calibration of models, and then some data pre-processing, post-processing, and other data provided by the FAO as well. So this is the, just to put in a context, regional context, the Apulia region, the study area, North Capitanata, South Capitanata, these are two irrigation consortia in Apulia region. There is, by the way, a kind of dry region anyway. And so there is lots of interest in this kind of topic. Without getting into the detail about the model of producing the land cover, high level land cover classification, because we basically use a machine learning approach. So here I just want to provide information of what the direction of that we took in terms of identifying crop rotation was, the rationale behind it. So let's say that we identify, because we know in the region there are these cover types, except for others. These were just to keep in the map, but they are not basically of interest for agricultural purposes. We identify vineyards, olives, and arable land. And then we said, okay, now let's go and sample some plots, in situ plots, where we know that there are some arable fields. And let's carry out a time series analysis, just taking advantage of all these, the open source data that we have from Sentinel-2, from the Copernicus mission, and with the purpose of identifying where the windows of presence or absence of vegetation was, okay, where. So in this case, we used vegetation indices, such as, this is just an example with NDVI for a demonstration purpose, where we identify, okay, we know that there is some green vegetation presence of cropland, some no green vegetation, so low values of this index for absence or bare soil for absence of crop. And so we put all together to try to identify this crop rotation. And this is basically the, it's a very basic methodology. Like we are also exploring something more like a more advanced, of course, modeling. But in this case, we were just trying to get advantage from the time series information and advantage from the knowledge that we have on the territory. In this case, on the study area, which is a polyregion, we know that there are maximum between 2 and 3 crop rotations. And so we set up some windows, static windows, and we identified these presence or absence of crops based on a simple threshold. Okay, and so this was the this is the output of this crop rotation for one of the 2 study areas. And this is another way of showing as a static image the dynamic on the landscape, on the territory agricultural landscape. And we use this information because we needed to know the specific, or actually kind of identify the crop specific that we needed to put into the FAO 56, the crop work model, because the crop work model works, of course, with crop specific information. And so for this purpose, we also try to apply methodologies to estimate the crop coefficients, and so to translate from the evapotranspiration of reference to the crop evapotranspiration specific using remote sensing still. This is just one of the methodology that we applied and that we can find in the reference as well, from mostly from Allen and Pereira. And at the end, we put all this information into CropWatt, which is based on the Penman-Monteith equation for the estimation of our reference and crop evapotranspiration, to come out with, okay, this is the reference, which is now crop specific, as you can see, and it's provided monthly. And then to identify some comparisons, differences, if they agree within each other, by simply using the crop coefficient derived by NDVI or remote sensing in general, and the FAO crop coefficient, which is basically a library provided by the FAO. And it can be somehow, misleading because it's not dependent on the climate conditions. It only considers the changes in, of course, the crop cycle. So specific crop, we know that it has a specific crop cycle, so increasing in the growing season, the peak, decreasing, and the senescence. But here with remote sense, we try basically to provide more information in terms of, okay, this is the static KC. With the Earth observation can be more dynamic because it depends. It's more like near real time, and depending on the weather conditions, the response on the sensor would be different. Of course, if something changed on the ground. And so this is just, again, we tried to do this because we needed to gain some knowledge for this pilot study, because then we got into a different study that is about the water digital twin, where we are basically updating another water balance model that is used by the National Research Council. And we are trying to give that plus with the remote sensing data by using all this information this knowledge that we gain by this project. So sorry for rushing, but I didn't want to keep everyone longer than the time schedule. So I think this is my last slide. Thank you again for the invitation. You guys, if you guys have any question, I'll be happy to. I'll do my best to answer. So back to you, Roya.
Thank you so much, Pietro, for your insightful presentation, and you were really mastering the procedure of the presentation. And thank you to all the participants that are still with us today. I open the floor if there are questions to Pietro. I see one from Ramiro Marco Figueira. What is the name of the project you are presenting?
Okay, sorry, I went very quick, but this was, it's it was called Riparti project, which is like a very short project, which to me actually one of these this kind of project, very short projects, allow us, because of the very quick deadlines, to get to the point right away. So it's very methodological. We do a very quick literature review of these projects during these projects, but then we want to address small problems in order to build up all this knowledge to bring to bigger project where we have more space, more of course more funding as well, and more longer time for producing something. So again, this was the Riparti project. We had two Riparti projects in this sense. In one of the first Riparti project, we addressed the estimation of crop efficiency using Sentinel-2, which is part of the methodology that we use in this second Riparti project. And so here we focus more on the crop rotation and integration of all these layers, informative layers, into the FAO crop watt model. So it doesn't really have a name as a project, but again, it's a very small project and involves university as well.
And Pietro, Livia Peiser, she had to leave due to other commitments and sends her regards. She wrote you, feel free to reach out to me or vapor@fao.org if you would like to compare ITIMO methods with our FAO vapor methods and tools, for example, using, and then she gave a link for everyone who is interested into that.
100%. Yeah, I can see the comment. Okay, yeah, thank you so much. 100%.
Okay. Then I think there were some exchanges on the presentation of Kozmin, but I think there you are settled. Are there any other comment to Pietro? Then let us have in the chat. Otherwise, I would like to thank all participants for having joined us. I think it was a very rich webinar today. I think we saw really good and illustrative examples and could see how really space feeds into challenges of the agriculture sector and how closely it is linked to water and soil quality. So with this, if you have any more material you would like to share with us, you can also send it to us via email. We will document the webinar on our website. You will be able to hear it. You will be able to access the presentation. I think most participants and speakers gave us the authorization to publish their presentation. And we stay with you tuned. We want to discuss this topic more in depth in the future. We will have future Space4Agriculture webinars. If you have ideas for topics, for cases to bring to the floor, please let us know. And with this, we wish you a very good day and very good weekend. Thank you very much for joining.